Hello, my name is Christine Reiner. I am the Communications Coordinator Contractor for the South Dakota Specialty Producers Association. Thank you for joining me for our greenhouse management webinar with Professor Stacy Adams from Nebraska Extension. This segment is funded in partnership with the Natural Resources Conservation Service, NRCS, and the South Dakota Specialty Producers Association to promote sustainable agricultural practices and environmental stewardship.
All right, good afternoon. This is Stacy Adams, and I'm with the University of Nebraska, Department of Agronomy and Horticulture. Primarily, my job involves extension and teaching in the area of greenhouses, controlled environments, modified structures such as high tunnels, as well as hydroponics and floral design and ornamental crop production. So we'll get started today. The topic is related to greenhouses, but I like to talk about it being a lot of our growers start out with high tunnels or other protective structures that don't have good controls as far as our environment, but they are a way for growers to step outside of the unprotected environment and learn how to start growing plants with a modified environment in order to improve their productivity. So the synopsis of the topic today is the rationale for why a grower might want to go to a greenhouse. We'll talk a bit about structural design and how we need to consider that design in relationship to what we plan to do with it. So what are our crops that we want to have? I want to consider the various controllable items. So when we move from a high tunnel, which is typically an open air type structure, now we have the capability of managing the environment and what tools and techniques will it take to do that. Some people have already gotten a high tunnel and they've attempted to use it, but they're considering, rather than investing in another structure, what would it take to convert that high tunnel into a greenhouse? So I want people to think about what the potential is and what the limitations might be, and then kind of set the framework for how we should plan for a brand new structure. Consider sites, infrastructure, and the positioning in relation to what the site is, and then I'll have a little bit of perspectives and takeaways. So originally, when a grower decided to do a high tunnel, they had too much exterior impact by the environment. So it might have been it was cold or early in the season, or maybe frost comes too soon. Maybe it's high winds, could even be hail. So the tunnel gave us an opportunity to continue to grow our crops that we typically would do outdoors, but we put it in this protective structure, so we're going to have a higher quality, visual quality, something that consumers would really like. So there was an opportunity to also increase the market because we can produce our crops earlier in the spring, get them onto the market sooner than in typical field production, as well as we can continue to harvest late into the fall, well beyond after the frost has pretty much taken out our field crops. There's limited property impacts with this. So these are low technology structures. We don't have to put a lot of infrastructure in. We can put them in, and if we decide we want to move it later, we can, or just eliminate it. So makes it pretty nice as far as a versatile tool. We also have the ability to plan our productivity. So seasonally, sometimes we have limitations of how fast our crops would grow, and the high tunnel allowed us to step forward into attempting to manage the environment somewhat so that we can predict our crops and maybe have multiple crops in relation to what we typically would in the field. I also brought up visual quality. One thing we have to think about is most of our specialty crops that we have are consumed fresh by our consumer. And anytime there's blemishes on there, it's unappealing, as well as texture can come into play. And if people are eating some of the lettuce and other products that has been out in an exposed environment, it tends to have a heavy, coarse texture that's not real enjoyable. And if we can move into a structure of any type, we can get more of a soft and supple growth that seems to be something that consumers would like to have. The other thing about tunnels is oftentimes it can be flexibly used. So we can grow in the tunnel in containers. We can do it in raised beds. We can do it in the field. Most people would use them with annual crops and do some speed cropping. Some people might want to use them for protection of berries. I know there are some people that further you go north, they struggle with the ability to have a long enough harvest period because sometimes winter sets in too quick. So we can have some permanent crops underneath of these. I was having a discussion with somebody the other day. Asparagus is probably one of the highest imported product that we have from other countries. If we would use tunnels, then we could have these tunnels help push the crop earlier in the spring, and then we'd have our outdoor asparagus that we could harvest. So we could actually add some sort of harvest period on it. So now let's think about greenhouses. That was tunnels. They're low technology. We just have an exterior cover and the ability to manually open and close things. And that's about it. If we decide to move forward for a greenhouse, we actually can do much more as far as managing the production environment. So we can set the temperature parameters in which a plant would really want to grow. We can schedule crops year round. Now there's a certain amount of limitation to that because as winter comes in, light intensity does greatly reduce, especially the further we are north. But we'll talk about that here in a minute. We can actually optimize the production. So oftentimes inside of a greenhouse, we're not growing in the ground at all anymore. And we're using containers, or we're growing in bag culture or pots. And we can strategize how things are going to go in there to make it the most efficient that we can have. So we'll maximize our crop as well as our operation. So a lot of efficiencies. And then the other thing is cleanliness. Now, there are some variables associated with the structural type, but whether you go with an active cooling greenhouse, so that's one that uses intake vents and fans, or if we use a passive system, there are ways in order to improve our cropping so that we don't have a lot of diseases and insects. Very important for our specialty crops, especially when they're consumed. So the considerations we have to have when we move into a greenhouse is what that initial financial outlay is going to be. And before we do that, we have to think about, well, what are the crops that we want to have? Some crops have a higher return, and it makes a lot of sense to invest more in a structure. So, for example, this structure you see here is out in central Nebraska. They wanted something very durable and heavy duty in order to handle the extreme weather conditions in the location. They wanted a clean site on the inside, so it has concrete floors sloping to a trough drain you can see in the middle, as well as they wanted the ability to grow hydroponic crops that were vining, so they needed a structure that could hold up the trellising system. So they need to calculate, is this worth our investment or not? Utilities, are they available? Now, I had my own greenhouse business for a period of time, and the location I was at, we had electricity and I had a well for water, but I didn't have any fuel energy. So we used propane. So that's something to think about. Key ones are water and electricity, because those are hard to actually make. Where when we get into the fuels, we have a lot of options available for that. So the results of what we build would directly attribute to the quality of structure and whether it meets what our specific needs are. And we can do a lot more with our crop management. So having this entirely closed system, basically a sterile facility, if you will. Now we can control all the parameters, environmental parameters going into it, as well as how we're going to manage our irrigation, humidity, CO2 inside of the structure, fertility, the whole bit. So a greenhouse has that ability for us to really manage our crop well. We do want to think about the structure and that it's designed appropriately to meet the needs. Now, as I said, this is that structure in central Nebraska. It's extremely heavy duty, not something we would typically see for most growers, but this particular rancher wanted to have a very durable structure. He was planning as a secondary income for his farm, and he didn't want to cheat the system. So he built it in such a way that he knew what his outcomes were going to be as far as heating and cooling and making sure he had a clean environment. We do have to consider what the crops are. So we're going to grow them in the ground, which is not very typical for greenhouses. And that has to do with the temperature stratification that happens inside the structure. And I'll touch on that here in a minute. Most things would be in some sort of a container, and that container can be as simply as a plastic bag filled with potting mix. It can be a pot, or it could be a specialized hydroponic type system. How many crops will we grow in this structure? Now, we do have some environmental restrictions that can come into play, and we have to think about how we're going to overcome those. So with a tight structure, we can add heating and cooling, but light is going to be our greatest limiting factor, especially as we get into the northern parts of the United States. So if that's going to happen, we have to consider, can our crop handle the lower light? If it can't, are we willing to invest in the electrical infrastructure in order to put in some lights? So do we want to have a single, multiple crops? Just to give you an example, the hydroponics that we do for ourselves, the tomatoes are a single investment per year. We run them for 10 months. So it's a single crop running through the whole area. But if we're growing lettuce, we're growing a new crop every 6 weeks. Maybe the farmer just wants to jump in for the seasonal period. So they want to avoid the coldest part of the winter when it's dark and gloomy. And that's how I used to run my own business, was we only grew what we call color and spring plant starts. So our greenhouse was only in operation from February till the end of June. And then we would start it back up for some late season crops in August, September, October, into early November. So we would avoid the worst part of the year. So it's something to think about. The crop that you're growing, are they going to be small ones, or are they going to be very large? Peppers, for example, those can get quite sizable, 5 feet high, 3 feet around. If we do tomatoes, if we're going to do determinate types, they'll be just as bushy, or oftentimes we'll use indeterminate, which I said are vining, and those will get extensively long, and we have to train them. So all this comes into play, and in a bit, we'll talk about whether we're going to use active cooling or passive cooling systems. As I said, the structure is designed for the crops. So they're on the upper left are some of my tomatoes from our hydroponic operation. That image in the center right is a cucumber facility in Cleveland, Ohio. That is not a messed up picture. I took it from the rafter, and you can see how that structure is just packed full of cucumbers. And then, as I said, on the bottom part, we have some bag culture. So that's 3-gallon bags with potting mix, and those are all peppers that you see. So we have a variety of ways that we can do our production system. The structures are designed for a variety of reasons. So these are actually 2 high-end structures. On the left is a traditional gable style house, and on the right is the raised hoop design, which is very common. Both of these structures are very significant in their design. So the engineering is well done. These structures don't bend in the wind. They don't twist and contort, but we have a significant investment in what they are. The shape of the structure will provide us opportunity for the ability to shed rain, hail, and snow. So that's why the gable design on the left is common in heavy snow areas, is to make sure that will slide off. The other thing is it captures light really well, and it can use what we call rigid covering materials. So the polycarbonates and the acrylics. Now on the right, we see the raised barrel hoop shape. That is a fairly strong structure. They can design them with various truss designs. So you can see this is truss. This one is gutter connected, and the gable one on the left can also be gutter connected. And what that does for us, it allows us to cover more area under a single roof. Anytime we can heat a larger square, we're more efficient than if we have a bunch of small structures. I wanted to show you that barrel roof. One of the problems we have with that particular style is the accumulation of ice and snow on the very top. But the nice thing about that structure is we can put 2 layers of polyethylene over the top of it, which is the least expensive covering. So kind of a trade-off on the way they're set up. I keep talking about passive and active cooling. Sustainably, so if we're considered sustainability, we like to reduce the amount of energy that we typically would use. Now, in the olden days, so we're talking before 1970, most greenhouses did not have exhaust fans and they used natural ventilation. And some of you may have remembered that they had a roof vent on the very top and then they had sidewall vents. And what that did was they could crack the top, it let the heat escape, and as the heat would leave, since hot air is buoyant, it would pull in the fresh, cooler air lower in the structure. Now, modern greenhouses, more and more are being designed with natural ventilation, and I'll show you those here in a minute. The investment is significant in order to do this, but there is one affordable low-cost option, which you see in the image on the right there, upper right. That's it, an inflation sidewall. So it's basically kind of like a air mattress that you would lay on at the beach, and it fills air. This one has a little fan, and when it fills with air, it expands and fits in with that track. I know people that have these. It's kind of a generally hate but love thing because it's an affordable option in order to create some natural ventilation. So what they'll do is they have the vents can open, as well as they'll open the doors on either end, or they'll have dampers that can open. So these things are low-cost options to running exhaust fan on a continual basis. In the lower image is a greenhouse that has window vents, intake vents, and exhaust fans. So we call that active ventilation. What that does is it allows us to contain the entire environment. So we can have screens, or we can totally close it up and use refrigerated cooling or chilled water. Not very often unless you're a research facility. But for most growers, they're going to use these intake vents with insect screening over them. And what that does is allows a grower to maybe be organically certified in their production on the inside, because they don't have to use chemicals oftentimes if they can control what's going in and out. Now, whenever we're using active cooling, that means we've got to run exhaust fans and intake vents. It uses quite a bit of electricity, plus there's some maintenance issues. For purposes of the topic today, I'm not going to talk about the different types of fans. Basically, you get what you pay for. So the cheap fans are cheap, they're loud, and they tend to fail. And the more expensive options are going to be much more durable. They're going to be resistant to environmental conditions, and they don't fail as much. So something to think about. Here you can see an image. This is from Ohio. This is 100% naturally vented structure. You can see that even though it has polyethylene roof, they're able to have that automatically open up, lets the heat out of the top, and then down low you can see that the sidewalls open up. This was in the middle of July. They didn't have a lot of plants on the inside, but it was fairly comfortable on the indoors. So a structure like this with the open roof design, we can actually maintain the temperature very similar to what it is on the outside of the structure. This one has active cooling. So this is that back at that farm in central Nebraska. I was involved in the planning, design, and installation of this structure. Very high end. It has an automatic block cloth system and evaporative cooling and the whole bit in it. But they must understand that they have to run a lot of electrical items in order to maintain the environment. On the flip side, though, they have much better control of the interior, and then they can time their crops so much better. Let's consider more attributes of the greenhouse environment. This is a low-cost alternative. Some of you may be familiar with Growers Supply or Farm Tech. There's a bunch of greenhouse purveyors out there. We'll talk about this specific structure. It was one that we used in a farmer relationship research project we were doing, looking at affordable options for specialty crop production. So we designed this one specifically for strawberries on the inside. But as I keep talking about, we have light as a component, and I'll talk about that here pretty soon. We have three aspects of light. One is quality. So quality means what the color spectrum is. And so we typically think of our natural lighting or daylight, sunlight. That's full color spectrum. But that quality can change as it goes through some sort of a product. So the glazing product will affect the color spectrum, if you will, of the light that's going through that. Keep in mind that plants are not perfect, but generally speaking, they absorb a lot of the blue color spectrum and the red color spectrum. So if you've seen an LED grow light, they're a magenta color, and that's the blending of the red and the blue together. And that is light quality. They're using the power just to provide that particular color spectrum because that's what the plants need. The other thing is light intensity. And as I indicated, that during the wintertime, oftentimes December, January, and February, light levels are at their lowest. And the intensity is so low that it's really even hard to grow some of the lettuce crops, and definitely with fruiting crops. You can still get some production, but productivity is significantly less. So if we're going to grow under natural lighting in the winter time, the intensity is going to be low enough. We have to weigh that into whether we're going to have enough productivity. Now, we can add a few LED lights, which will trick the plants into thinking that there's more light and they'll be more productive. But once again, we're using electricity to make that happen. The other thing is light duration. So light duration during the day changes through the season, especially for us in the northern environment. So equinox is September 22nd and another one in March 22nd. Roughly, those are the days. So anything between September 22nd and March 22nd, the days are shorter than how long the nights are. And vice versa for the summer. So from March 22nd to September 22nd, the day period is much longer, or becomes much longer than the night. And that is a photoperiodic response, or plants respond to that through photoperiodically on whether they're going to flower or not. So it's something to think about, that when we grow under natural day length, we have to determine, are the crops we're going to grow day length sensitive or not? Example being chrysanthemums, poinsettias, sunflowers are all photoperiodic crops, and we have to make sure we give the plant the right length of light. Otherwise, they won't be vegetative or they won't be flowering. So kind of one of those tricks that we have. We have heating controls, cooling, and ventilation, and then sanitization, as well as is the facility designed in such a way it can either be flexible in its space use on the inside, or as I said with hydroponics, oftentimes we create these to be dedicated to produce a certain crop. So let's take a look at glazing. We talked about light here. On the left is a typical greenhouse we might find in the Midwest. Oftentimes is related to the farmer's ability to have a return on investment. So they'll start out with a structure, we call this a hoop design, and this actually has polyethylene over the top. And it looks like it's just as bright as anything, but we'll find that only 70% of the light that the sun is sending our way will actually make it into the structure. So though that plastic looks like it's clear and bright, it's actually providing as much as 30% shading on this interior of the structure. So oftentimes if a grower is going to be producing plants in the middle of winter, they want to go something that has a higher ability to transmit light. And one option is on the upper left, which you see is the twin wall polycarbonate sheeting, about a 92% light penetration through there. So you can see we've already increased the light by about 18-20% in comparison to the twin wall poly, or two layers of polyethylene. On the lower right, you can see glass greenhouses, very high investment, typically going to be large corporate growers that are wanting to maximize light during the winter. And the only way they can be profitable with their greenhouse is by having maximum production coming out of there. So they have to be highly efficient in everything they do. They know that the highlight is going to be critical. Now, something, if you look at that image there on the lower right, you'll notice that it's kind of got an XY shape there in the middle. That's actually in a fully opening roof or atrium roof on that particular greenhouse. As I said, one of our big expenses in the greenhouse industry is the cost of our energy. So by moving to these natural ventilation, then we don't have to run fans at a continual time. Covering installation is interesting because there's different ways it can be put on. On the upper right there, you can see the polyethylene, twin wall polyethylene is very simply applied. That's why a lot of people like it. Not only can they put polyethylene on almost any structure, but they can buy a poly locking system. So it has a base channel and then something people call wiggle wire. Oftentimes, I call it spring lock. So the two layers of polyethylene lay in that track, and then you just wiggle the wire in, and that locks it in. Though it's cheap and easy, there are some issues associated with it. Primarily, we don't have a continuous seal on there. You see it kind of wiggles up and down, and it causes a strain everywhere that plastic is being pinched. If you have a lot of wind, sometimes it can wear holes in those particular areas. But generally speaking, for 1 or 2 year installation, it does just fine. And if you maintain the proper blowing up or putting air in between the two layers, and you can keep the tension on the poly uniform, then we have a lot less wear. Some growers don't even want to deal with the polyethylene because if you lose power, then the poly deflates, can flap the wind, that causes problems of it. So some want to invest in something a bit better. The image on the left actually has twin wall polycarbonate on it. You notice they have it on the roof. This greenhouse is 36 feet wide, so it's wide enough that polycarbonate is able to make that gentle bend. It does use a 2-lock system, so there you can see it on the lower right. This one's a little more complicated because it's designed also for glass or acrylic. They do have a less expensive option for the twin wall polycarbonate that you see on the left, but they're usually a 2-piece bracket, something that's a receiver, the glazing goes in there, and then you have a top cap that's screwed into place. Now, there's not a lot of tolerances in these, as you see. Usually about a 1/2 inch lip is all that this glazing is sitting on. So for this reason, we have to have a structure that will not twist and contort, because then the glazing will slip out of its channel, and then we have issues where wind might get there and pull off panels. So when we start moving to these more expensive, durable, hard coverings, we need to make sure that the structure is such that they will have their greatest impact as far as how long they can be used. This twin wall polycarbonate that you see there's probably got a 20-year warranty, but generally it remains clear enough for most growers for about 15 years. And then they need to consider changing it because this product does tend to yellow over time. Heating is something else that we need to be aware of on these structures. On the left, you can't see it, but some people like to do boilers, and we can use natural gas or propane boilers, or you could use a wood burner if you wanted, anything to heat the water. And here you can see that the water comes in, it goes down into the concrete and heats the floor. This is a undersized system. I just wanted to show you how that manifold would lay out, and then the hot water would go in and it would heat the concrete up is what it does. And the concrete serves as the ability for that the heat to be transmitted into the growing space. Now, most growers are going to be using that heater, as you see in the middle top picture, which is nothing more than what we call a unit heater. Everything happens in it. It has the heat transfer occurring inside of it. Has a blower fan. It's got its own control system in there. And then we have a ventilation system. So unit heaters are very easy to just purchase. You can get them in a variety of efficiencies. Most of them are around the 88% energy efficient. You can get one that's more than that, but you have to, once again, balance your costs. You do want a unit heater that can handle the high humidity situation. And we need to make sure that it vents well, because we can't have incomplete combustion getting inside the structure. In the middle image on the bottom, you actually see one of these 99% heating units. This is one in where the heat actually, well, the fuel is burnt inside of it. It blows the entire combusted fuel heated into the greenhouse structure. It's not something we would typically want, because there is a high risk of carbon monoxide poisoning with that. And when you use those, you must have an exhaust fan on the other side that runs at the same time that the furnace runs. So that's kind of one of those tricky units. They sell them in industry, and I think it would be a big concern if you have workers trying to work inside the structure because of the way that system works. I still see them out there. They use them sometimes in confinement houses and things, but just be aware that they can be a tricky system. I prefer the one on the upper, the middle image on the top. Now, I indicated that the thing about greenhouses is that the temperatures tend to stratify, so heat rises, and that heat will capture in the top of the greenhouse, and oftentimes the floor will be really cold, especially that lower 12 to 16 inches will be extremely cold. That's why I said most growers will not grow their plants in soil, because the ground would be so cold that the roots can't grow and they can't efficiently work. So the vegetation of the plant, though, will continue to respire and try to grow. And oftentimes the plant will have some real health issues because we won't have a good balance between vegetative and root growth. So something to think about. So that fan on the lower right there is a vertical fan. So it captures the heat from the peak of the greenhouse and blows it. Well, I think this one, the way it looks, it's actually sucking the air upward, and then it has that that hood on the very top of it that pushes the air outward, which makes the air blow against the greenhouse glazing and then back down to the floor. That's really important for, especially if we're growing any crop that's going to be potentially get downy mildew or powdery mildew, because oftentimes we have troubles with that during the cold part of the winter as well as high humidity. That particular fan will improve air movement within the structure. It'll dry off that moisture from the glazing so the water doesn't drop into the crop. And then it balances the temperature between the floor and the ceiling. I did talk about different types of cooling. So here is a hydroponic greenhouse, actually in the north part of Nebraska. Traditional farmer has this gutter connected system. So this is like an 84-foot wide by 100-foot long tomato operation. It's a super cool operation. It was affordably done. It does have twin wall polycarbonate on it. They have active ventilation on it. There on the lower left, you can see inside of our strawberry research project that we had worked with a farmer on. It's that lower structure, and it has a direct dive fan in there. So we just need to make sure that we have enough cooling to meet the needs of when we're growing crops. Now, most of the time, we can grow our crops outdoors in the summer, and the greenhouses can get quite hot. But during the winter, fall and spring, we might be growing crops on the inside, but if we have a really sunny day, the greenhouse could get quite hot. So we need to have the ability to bring in gradually some air too. So it's going to be a combination of different types of intake vents as well as the exhaust fans that we're going to use. I do like this greenhouse. It was one of my favorites I've seen. This is in Columbus, Ohio, and I see this as the future of what greenhouses are going to be. We're starting to see more and more of these open roof designs. This one is modern, but it was an affordable option to the cost of some of them. So something to think about. The way these work is by having the window panels open up from the gutter side. They can do a complete opening of the roof, allows a chimney effect where the heat can go up, cool air drops in. So this works well for those late spring, summer, and early fall periods, but they would not work real well during the winter period because it would get way too cold. So we have to have a combination of heating and cooling methods depending on the time in which we're going to be growing our crops. I want to touch really quickly on light. These are some older lights on the left, but I like this picture because it's got a combination of light types. Some people are frugal and they'll save some old lights from maybe gymnasiums or something, and those are called metal halide lights. You can see it in this image on the left. They're not efficient, but on the front here, upper left, are LED lights, and those are designed specifically to meet the color spectrum in which plants need it. Now, this is an older type of LED. They're just ever improving the quality of these LEDs, but you do need a LED grow light designed specifically for plants. Yeah, so on the upper right, you can see my strawberry research I worked with some people on. That was that low technology structure. It was still a greenhouse. We have the open roll-up walls on it. We have circulation in it, but we didn't add any light. And so that project was just exploring, could a farmer grow strawberries with a minimal cost input in order to be productive? Strawberries, if you can get strawberries out of the market really early in the season, you can get a great return on your investment. So that's what we were doing on that. Yeah, so let's look at these different pictures here. On the upper right is an example of a problem that we have when people do not think really well about how they want to produce their crops. So here they had some gravel on the ground that over time had gotten kind of sediment and muddy in there. They're also growing the crops on the ground. Now, for their particular application, it was okay because this was perennial crops. They were just trying to green them up in the spring. So very minimal investment. They have a furnace in there so you can get early season heat on there. You see an exhaust fan on the back right, that big black box back there, and that's an exhaust fan. So very inexpensively done, but it would be very difficult in order to manage that interior. For perennial plants, they're okay for quick sales. But if you want to really control that crop and you want to have good sanitization, you want to think of on the lower right down there, where even though they didn't put concrete everywhere, they have a concrete sidewalk so they can at least use carts and their different equipment can move easily down and back. And then they had a sand layer on either side, and they used wheat fabric. And look at how clean that is, and it's much easier to sanitize that. And then on the left, of course, this is a hydroponic operation. It was actually a greenhouse that was converted from traditional production into hydroponics, and it had concrete floors. But concrete is real expensive. The other thing, though, about on the left there is you see the hydroponic operation. And a neat thing about hydroponics is we don't have a lot of touching of the product. So these were just planted, the system will run, and then only the other time they're going to be touched is when they're harvested. So unlike some of these other systems where there's the potential for a lot of contamination from splash and from handling, the system on the left, much more engineered, a lot less touching, which is a lot less potential for some sort of disease and diseases and insects. I need to move along here. So one thing you might want to consider is high tunnel conversion. So this greenhouse you see there on the right is the one of them that I had, and it was one of those portable greenhouse structures they used to put in parking lots. I modified it, made it into a greenhouse. So you have to think about, is the structure going to be able to handle it? What's the quality of construction? So can we make it really tight? Can it handle the environmental conditions throughout the year? Can it shield the rain and the snow? So all that comes in play. The other thing you have to consider is the legal ramifications of it. So if you're in a rural location, you might be okay, but once you heat the greenhouse, then it's going to be maybe fall in the building codes a little bit different, and it may not meet what those codes are. Maybe they'll let you grandfather in, but it is something that you want to ask before you get too carried away. If we do convert a high tunnel, we have to think about, well, can the structure handle holding some of this equipment or the crops that we put on the inside? So on my structure you see there, I actually had the furnace suspended from the support of the structure, and I had troubles with the furnace bouncing when the greenhouse got too in a windy situation, and that was unacceptable. It's too hard on the equipment, so we had to strengthen up the area. So something to think about in that conversion process. There's a high tunnel on the left. Oftentimes those are just posts are just stabbed into the ground, so it doesn't have much structure. Here on the upper right, once again stabbed in the ground, and they just put some a baseboard on, and then on the lower right, that's a continuous foundation, which is going to be significantly more investment. Why this comes into play is, one, I said, if we support equipment hanging from the ceiling, that'll keep it from wanting to sink. If you're going to be like hanging cucumbers or tomatoes from the structure, there's a lot of weight that's going to be in there. So we need to think about what will happen on that. If we build new, so we need to pick a greenhouse that meets the needs of our crop. So if we're going to do crop like this here, these are geraniums and some baskets, and our structure doesn't need to be as big as something else. We talked about whether we need to have a pier. So that means we can just put concrete boots basically wherever post is, or will your governing entities require you to have a foundation? So these are all questions you need to ask. Then we've talked about sanitization and how we're going to grow our crops. So you do want soil on the floor. Well, that's a disease problem. We can put ground cloth, gravel, or concrete on there. And then think about what the workspace and storage is. In my greenhouse, I didn't have a workspace, so we had to use some of the greenhouse that we could have been growing crops to do work. So that's something to think about. And then if you're going to try and harvest your product, how are we going to move, how we're going to get it and move it to wherever it needs to be, box it, and then ship it. This is what can happen. Upper left, this is in Michigan. I was there, and they had a storm. The greenhouse was not placed in the right direction. It caught the wind. So I can't give you a perfect location or siting on your greenhouse. You just have to evaluate where it's going to be. This particular greenhouse was on a north-south direction, which I would typically recommend. But they were 10 miles from the Great Lakes, and the storm would blow off and it would catch the structure. So you can see it damaged that one greatly, but if you look at the one behind, it was just fine. And that's because it was working with the wind. So keep that in mind, what that structure can do. On the right, you can see that one has an open structure, and it makes it easier for the farmer to suspend their crops and harvest them. However, there's not much trussing on the inside, so it would be a vulnerable structure for collapse if we got heavy snow or ice load on top of it. I want to show you this structure. This is back in Michigan again. This was a poultry barn that had converted into a greenhouse. You can see the wooden structure. It was extremely large. It was 40 some feet wide and about 200 feet long. They produced a lot of crops, but look at all those hanging baskets over the top. The structure was not designed to hang all those up. And they had a clone of this facility right next door, and it collapsed under the weight. So when I went to visit them, they showed me the old structure, and then they had a brand new structure on the other side. So keep that in mind that, yeah, we can repurpose structures, but we really need to think carefully about how we're going to, or in what ways would that structure allow us to safely utilize it. In the essence of time, I think I'll just move a little longer. Most greenhouse manufacturers will come up with some really good designs. This one bothered me on the upper right. It is from a greenhouse supplier, but you'll notice that there is a very weak connection there between the trusses and the support posts. We would like to see a knee brace there that would prevent this from wanting to move back and forth. But this is all the types of things you need to consider when you're talking to a greenhouse manufacturer and what they're going to supply. Many greenhouse companies are out there, and they're going to have a greenhouse to meet your budget, but that doesn't necessarily mean that it's the right structure for you. So here you can see much better connections the way they're designed. You can see the truss on the other side on the left there, as well as we want to think about the steel dimensions. So on the right, we have 3-inch square steel, a lot better bolting system and how everything comes together. So think of whether you can get engineered plans and whether they've been tested so you know if it can carry snow load and what the dead weight can be on it. This is just showing you an example. This was back at that greenhouse where the poultry barn had collapsed. This was their new structure, and you notice that they're growing both on the floor as well as hanging stuff over the top. So then they have to think about how we're going to lay it out to move around. So on the left here, you can see a high tunnel. Those are just ground posts stabbed in the ground. This is a little bothersome because the green or the high tunnel is kind of going up a hump there, and you notice that the posts aren't really straight. So this is the problem that we have when we're looking at somebody having a high tunnel and converting it to a greenhouse. There's just the potential for a lot of issues. On the right, that's inside that hydroponic greenhouse in Nebraska, and you can see they have it on concrete. Makes a nice clean structure, very strong, heavy-duty, designed specifically for the crop on the inside. Various types of floor surfaces. Gravel's hard to walk on. It's hard to clean, keep from insects and diseases. So something to think on that. We have to think about how we're going to control things. So on the upper left is just the old method of using a bunch of different thermostats, but more and more we're using computerized controls, and these microcontrollers are becoming so much more affordable. It allows the structure to maintain the environmental parameters in which you wish to have. As we wrap up, I just want you to think about site development. So there's a greenhouse on the top. That was one of my houses, and you can see it's kind of sitting on a piece of land that I had graded specifically. Actually, while looking at that image, you'll notice that it's got a corn bin over there on the left. We used to burn corn during the coldest part of the winter, and then we've moved to propane when we had the variable temperature. So just a lot of things that you can do with it. The greenhouse down here on the bottom is from New York when I was visiting there, and you'll notice that they just built the greenhouse on the hill, and that's going to cause a lot of problems for managing that structure as well as how we handle the crop on the inside. So something to think about on that. So basically, in a nutshell, hopefully for today, that you think about these structures. First of all, we want it to be safe. So that means safe for the worker, but also safe for your neighbors. We want to align the greenhouse design to meet that for the crops. Consider what your investment is and the return on it. If you know what your crop is and you've experienced it before in the field, you already have a better understanding of the crop. Then when you move into greenhouse, there'll be new challenges for it, but at least you'll have the basic understanding of how crops are growing on there. Through the use of these different protective structures, what we're actually doing is we're increasing productivity, speeding the time in which we do it. we can be more precise in when the harvest can be, and hopefully more productivity. So then we have to think about all the market potential we could have, which means more money. So with that, I want to thank you for inviting me for today, and I hope that you were able to take away some great information.
Thank you for joining us today, Stacy. We appreciate your time and knowledge on greenhouse management and all of the different aspects it takes to create something on that large of a scale. For more information, if you want to contact Stacy, we do have his information in our description. Feel free to reach out to him or Nebraska Extension with any questions you have. This segment has been funded by a partnership with Natural Resource Conservation Service, NRCS, and the South Dakota Specialty Producers Association to promote sustainable agriculture practices and environmental stewardship. Again, my name is Christine Reiner. I'm the Communications Coordinator for the SD Specialty Producers Association. Please visit our website if you would like more information on upcoming events at sdspecialtyproducers.org.